Yo, yo, algebrainiac! Welcome to the Johnson Kendro Video Hour!
But it's not an hour.
Alright, well, life is short, so an hour is not that long. Alright, let's talk about properties of exponential functions. Yesterday we graphed y equals ab to the x, but all the a's were positive. If a is negative, it's basically reflecting that graph over the x-axis. Right. All right, so let's try this example. Y equals 1/2 to the x. So a is 1/2 and the 2 is your b. So we need to plug in the -3 in for x. So I have 1/2, 2 to the -3. Now if I put that on the bottom, that becomes 2 to the 3rd. So it's 1/2 over 8. Now, do you know that we can make that 8 over 1 and then we flip and multiply? So I get 1/16.
That's really small.
That's tiny, so we'll see how that graphs. Then we have 1/2 over 2 to the -2, which is 2 squared on the bottom. That's 4.
So
Make it 4 over 1, 1/4. So that would be 1/8.
Ooh, the next one's going to be 1/4.
Right. This number here is kind of telling us that we're plugging it in with that, but then this number here tells us what it's changing by.
Okay.
All right, so next will be 1/4.
1/2. 1, 2, 4.
Okay, that makes it simple. All right, let's graph. -3 to the 1/6, or 1/16 is there. -2 and 1/8 is somewhere in there. -1 and 1/4. All right, real close.
Too small to graph.
Yep. 0 1/2. 1 1. Now it's getting easier. 2 2. 3 4. All right, so our graph is going to look like this.
And remember, we talked about that horizontal asymptote. That funny word.
Right. It never quite reaches it.
Okay, so that was a positive A. So let's see. That was just like what we did before in the other section. So let's see what happens.
All right, let's try it with the negative.
Now, wait a second. Aren't you going to get like all the same numbers from the other T-chart? But
well, they're going to be negatives.
Negatives.
So we can just replace it.
All right, so that was -1/16, -1/8, -1/4, -1/2, -1, -2, -4.
All right, try it again. So -3, -1/16. It's right there. We're going to have this issue again. There, -1, -1/4, -1, -1. Whoops, I forgot 0, -1/2.
1 -1. There you go.
2 -2 and 3 -4. So this one's falling. The other one was rising, and then we have our dotted line here.
Horizontal asymptote.
Yes. We talk about asymptotes a lot in trig too, so it's good to know what those are.
Okay, some things to think about here. The horizontal asymptote's exactly the same. It's going to be at y equals 0, even though it has reflected over the x-axis. It doesn't change. You're going to see a couple of these on your assignment, so I wanted to talk about those first. Is there a difference between this and this?
I would think so, because that negative sign in the parentheses goes with the 3.
Right, so that means the exponent would apply to that?
To both of them.
What about this guy?
Only the x goes with the 3.
So let's think of this, when you see this without parentheses, as -1 times 3 to the x. That means your a value is -1 and your b value is 3. So this is going to be your y-intercept, and then this is your growth or decay factor.
So in the other one, over to the right, a would be just a plain 1.
Right.
And
this
b
is
would
growth
be
or decay,
negative.
but they actually don't see that in this.
Okay.
Because it's not exponential.
All right.
Okay. Let's do some more graphing. Your favorite.
Yay, translating.
Okay.
Okay, this is the h and k here. That's going to tell us to move either right or left and up and down. So the h tells us right or left. And now it's a -h.
So that's the backwards thing, like
Right.
always.
Just like it was with parabolas.
Parabolas, absolute values, square roots, everything.
Now, so the right is a minus and the left is a plus.
Correct.
When you see that up there. And then K, up is plus and down is minus like you'd normally think. Okay.
In the shape chart stuff, same stuff we've always done before. You're going to make your T-chart for the easy thing.
Right. The H and K gets done later.
Yep, that's shifting. Okay, let's try one.
Get that purple blob out of there. All right.
Now I got blue dots all over.
Purple blobs and 2 blue dots. Okay, we're getting fancy. Okay, so we have to do our shape chart. Parent function, yeah.
AKA parent function.
Yep, yeah. Same deal. So we can do points again. We've got this as our shape chart. So you can pick the same kind of numbers as we did before. We did
-3 to 3. We say that's a good starting point, but maybe we could try -2 to 2.
All right, we'll see. -2, -1, 0, 1, and 2.
Okay.
So if I have 4 to the 1/2, or sorry, 4 times 1/2 to the -2.
That's flip and multiply.
So again, we have 1/2 squared.
That's 1/4.
That's 1/4. Flip it, we get 16.
Okay.
Then I get 4 over 1/2 to the 1. Flip it, I get 8. So it looks like we're cutting them in half.
Which makes sense because our little decay factor is a half.
Okay, so
then
putting in a 0, we'll get 4.
A 2, a 1, and then would be 1/2.
Right,
so
keep
4.
going.
Okay.
So let's plot these.
All right, so -2 is 16. That's probably too big to put on my little graph here, so I'm just going to start with this guy. So -1 is 8, 0, 4, 1, 2, 2, 1, and the 1/2 we talked about. That would be this thingy. You guys can put it on there, that's okay. But then that's not our final answer. And also remember your asymptote would have been right there. That's really important. But this thing is going to shift according to the H and the K. So where's it going,
So we go left 2.
Left 2.
And up 1, or up 3.
Up 3. Also, this thing is super important because when you slide something up, the asymptote is also going to slide up.
Oh, it shifts.
Yeah, so it might be helpful to put that in there. So I'm going to take each of these dots and move them left 2 and up 3. Left 2, up 3. It helps if you make those sound effects.
Left 2, up 3.
Is that right?
It's hard to see when you're that close to the graph. Very nice.
Thank you.
Attention, Jefferson's Brave Book, if you are in the building.
All right, well, I don't have Jefferson in my class, do you?
Nope.
No? All right, well,
moving on.
We can move on then.
Okay, so remember the original asymptote would have been y equals 0, but we shifted everything up. So now it's at y equals 3, and that's always going to correlate to the k value.
All right.
So
That seems pretty
know.
easy to remember.
All right, that's it for graphing. So now we're moving on to word problems, which are your favorite, right?
Mm-hmm.
Okay, so half-lives are the first thing that we're going to cover. Half-lives, you've probably heard about that in science class or chemistry, biology type things. That's the time it takes for half of a substance to decay, for instance, radioactive substances. So I have a real-life example.
Ooh.
I hunted it down on the internet.
The internet's kind of a cool thing.
Yes.
I'm glad Al Gore discovered it.
All right, so a hospital prepares a 100-milligram sample of this fancy stuff called technetium.
Technetium.
Which has a half-life of 6 hours. So what that means is after 6 hours, you'll have half as much as you started with. Write an equation to represent the situation. Let y equal the amount of technetium and x equals the number of hours that have passed. So when we're working with half-lives, we're going back to y equals ab to the x power, but something important is the exponent there. It's not just time. It's not just hours. It's the number of half-lives.
So we're not going to put a 6 in there.
Right.
Oh, no.
Right. One half-life is 6 hours. So for instance, if I told you 12 hours have passed, how many half-lives is that?
2 half-lives.
Because what you're really doing is dividing by 6. So our exponent's going to have division. I also have a pretty picture to show you.
Ooh.
So this is technetium. I couldn't find a human, but I found a cat.
Oh my, that looks like a heart. Are they doing heart surgery?
They're not doing heart surgery. That's actually, I think it's thyroid cancer, they said.
Aw.
So what they did is they injected this cat with the technetium, and the technetium clings to abnormal cells. So
Wow.
he's got thyroid cancer.
Aw.
So that's sad.
Do you like cats?
I love cats. I have 2 cats.
You do? What are their names?
Max and Macy.
Max and Macy.
Yeah.
Very nice. I'll have to come visit them. Although they make me sneeze a little bit.
No, that's okay.
Yeah.
They'll stay away.
I can handle it.
All right. Okay, so we need to write a exponential equation. Remember, A always represents your starting amount, and we are starting with 100 milligrams.
So you can remember A for amount.
Yeah.
A amount.
That's good. And the B is the decay factor. Now, they don't explicitly say this, but what is happening to this stuff again? We're cutting it
In
in.
half.
So every time you do a half-life problem, your B is always going to be a 1/2.
That's pretty easy.
All right, then your exponent, this is a little different. This is what we were talking about here. So it's not just x, because x represents the number of hours. You have to take the number of hours that have passed and divide it by the length of a half-life.
Gotcha.
All right, so that's the equation. That's the first thing that we're going to be asked to do. And then the second thing would be to do some sort of calculation. So now they're going to tell us after 75 hours, so in this cat, how much technetium is left. So here they want us to find out how much technetium has passed after 75 hours. So this represents time. This is our x value. So we're going to set up our equation we just created, only now our x is being replaced with 75. Now be careful when you type this in. Some of you like to just do it all at once. I'm doing it step by step. So I'm doing 1/2 to the, and then in parentheses, either doing 75 divided by 6 or simplifying first. That's 12
Can't
and a half.
multiply the 100 times a half to get 50. Because
Right.
That's not following the order of operations.
Yes,
You gotta do
you got to do this
first.
part first. Okay, so 75 over 6 is 12 and a half. So in my calculator, I typed in 1/2 to the 12 and a half power,
Mm-hmm.
and I get something super duper small.
Okay.
And then I'm going to do that times 100. And I still get something super duper small. And we can round to the nearest tenths or the hundredths place.
Okay.
And I think this was milligrams, wasn't it?
Yep.
Yep.
So it started out with 100 milligrams, and now it only has 0.02.
I got a question for you. Will there ever be 0 milligrams in the cat?
Technically, no.
Technically, no, because it just keeps getting cut in half, 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 half.
Right. So there'll always be a teeny tiny bit left.
But it'll probably be so small. There's no
You
trace.
can't tell.
All right.
All right, kiddies, that's it for now. We'll see you in class.
Bye-bye.